A very good morning to all of you. This is third video from the unit arithmetic progression. In the last video we have defined arithmetic progression and also we learned about the algorithm to determine whether a sequence is an AP or not. But it was only when we are given an algebraic formula for the general term of the sequence. Here in this video, we will learn that whether if we are given a list of numbers, then can we say that this list of number is an AP or not? And also, depending on this observation, we will find the first term, common difference, and also the next term of the arithmetic progression. Let us make the concept more clear through some examples. And here in example 1 I have, for the given AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2 and so on, write the first term, that is A, and the common difference D. Since in the question here it is already given that the given sequence is an arithmetic progression. So from here we have the first term A is equal to 3 by 2, and we know that common difference we can find by getting the difference of any two consecutive numbers, consecutive terms. That is D is equal to, I have taken here 1 by 2 minus 3 by 2, which results in minus 1. Remember that we can find common difference using any two consecutive terms once we know that the numbers are in AP. Moving ahead, let us consider another example. And in this we have, which of the following list of numbers forms an AP? That is, we have to check first whether the given list of number is an AP or not. If they form an AP, write the next two terms. So I have considered four subtopics. In the first we have 4, 10, 16, 22. So finding the difference, that is second term minus first term, I have 10 minus 4 is equal to 6. In the same way, third term minus second term, again I am getting 6. Fourth term minus third term, it is equal to 6. That is, the difference between two consecutive terms is the same every time. So the given list of numbers forms an AP with the common difference D is equal to 6. Depending on this, we can find the next two terms, which is 22 plus 6 equal to 28 and 28 plus 6 equal to 34. Second subtopic, we have the list of number as 1, minus 1, minus 3, minus 5 and so on. So we will find the difference between two consecutive terms, that is A2 minus A1 gives us minus 2. A3 minus A2 gives us minus 2 again. And the difference between fourth and third term also gives minus 2. That is, the difference between two consecutive terms is the same every time here. So the given list of numbers forms an arithmetic progression with the common difference D is equal to minus 2. And so the next two terms are minus 5 plus minus 2, which is equal to minus 7. And next to it, it is minus 7 plus minus 2, which is equal to minus 9. In subtopic 3 we have the list of number as minus 2, 2, then minus 2, then 2, then minus 2 and so on. So Here also we will find the difference between two consecutive terms. So second term minus first term, it is equal to 2 minus minus 2, which results in 4. And difference between third term and second term, it is equal to minus 2 minus 2, it is equal to minus 4. So what we observe here, as the difference between second term and first term is not equal to the difference between third and second term, so the given list of number does not forms an arithmetic progression. Now consider subtopic 4, and here in this we are having 1, 1, then 2, 2, 2 for 3 times, then 3, 3, 3, and so on. Again we will have to check it whether it forms an arithmetic progression or not. So find the difference between two consecutive terms. A2 minus A1 gives us 0. A3 minus A2 gives us 0. Whereas difference between fourth and third term gives us equal to 1. So here what we have? Difference between second term and first term is equal to difference between third term and second term. But it is not equal to the difference between fourth and third term. So the given list of number does not forms an AP. Now let us consider another question. And here in this question we have, write an AP having 4 as the first term and minus 3 as the common difference. And as we know, there is arithmetic progression with first term A and common difference D is given by, in the general form, A, second term is A plus D, third term is A plus 2D, in the same way A plus 3D, and so on. That is, each term is obtained by adding D to the preceding term. And here we have in the question, first term equal to 4 and common difference is equal to minus 3. So the arithmetic progression is 4, then for second term we have 4 plus minus 3, then for third term we have 4 plus 2 into minus 3, then for the next term we have 4 plus 3 into minus 3, and for next term I have 4 plus 4 into minus 3, and so on, which results 4, 1, then next term minus 2, then next to it is minus 5, minus 8, and so on. Now let us consider a different type of question which seems like a words problem. And here in this question I have, in which of the following situation the sequence will form an arithmetic progression. In subtopic 1 we have, number of students left in the school auditorium from the total strength of 1000 students when they leave the auditorium in the batches of 25. In subtopic 2 we have the amount of money in the account every year when rupees 100 are deposited annually to accumulate at compound interest at 4% per annum. One by one I will consider both the subtopic. So for the solution of first, in the first we have the total strength of the student in the auditorium. It is equal to how much? 1000. Therefore, number of students left in the auditorium when first batch of 25 students leave the auditorium. It is equal to how much? 1000 minus 25, which is equal to 975. For the next term, what we will have? Number of students left in the auditorium when second batch of 25 students leave the auditorium. So we will have to subtract 25 from 975. That gives us 950. In the same way, number of students left in the auditorium when third batch of 25 students leaves the auditorium. So we will get from 950 minus 25, which is equal to 925, and so on. Thus, the number of students left in the auditorium at different stages are 1000 in the beginning, that is first term, then second term it is 975, then it is 950, then next to it is 925, and so on. Clearly it is an AP with the first term 1000 and common difference minus 25. Moving ahead, let me consider subtopic 2, and in that the question was the amount of money in the account every year when rupees 100 are deposited annually to accumulate at compound interest at 4% per annum. As we know that if P is the principal and R% per annum is the rate of interest, and if it is compounded annually, then amount A at the end of n years is given by the formula A is equal to P in bracket 1 plus R by 100 whole raised to the power n. Here n is the time. So in the question it is given principal P is equal to rupees 100, rate of interest R is equal to 4. So we can find using the formula for the amount of money. A is equal to 100 in bracket 1 plus 4 by 100 whole raised to the power n. After simplification we will have 100 in bracket, we will have 104 by 100 to the power n, which gives us 100 into 1.04 to the power n. Thus, the amount of money in the account at the end of different year is given by, for the first year we will have 100 into 1.04. For second year we will have 100 into 1.04 to the power 2. For third we will have 100 into 1.04 raised to the power 3, and so on. So here after simplification I have for the first year 104 rupees, second 108.16 rupees, for third it is rupees 112.48, and so on. And since you can find the difference is not the same, the difference of the two consecutive terms is not the same here, so clearly it is not forming an AP. Thank you for today.